We are going to get into lesson, oh my gosh, George is so excited. We're going to get into lesson 29, which is the final lesson of module 2. Are you excited, George? Excited. We're going to tackle a pretty beefy, oh, my hair's crazy. We're going to look at a really, really big word problem with multi-steps. And then tomorrow, George, they can handle it. They're really, really clever kids. And then tomorrow in class, we're going to work on some more problem solving. Tuesday, we'll do our review before we celebrate our learning on Wednesday and Thursday. So it's going to be a great week, our final full week before winter break. Looking forward to it. So here goes nothing. Say bye, George. Oh, I'm so excited. I am speaking softly because George just fell asleep. All of that math really wore him out. Well, I guess the talk of math really wore him out. I found the coolest problem. I'm really excited to kind of get into this one because I think this is just a really, really awesome problem that gives us an opportunity to access that great learning that we've done so far, all of the great learning that we've done so far, and apply it to like a pretty thought-provoking problem. So let's get into it. Okay, so we're going to look at number 4 here. A city block is 3 times as long as it is wide. If the distance around the block is 0.48 kilometers, what is the area of the block in square meters? Oh, this is an awesome problem. Okay, so let's just create a visual so that we can wrap our heads around exactly what we're given in this problem, and then we can start thinking about how to move forward. So we know this. We're just going to organize the information that we've been given. Okay, so here's the city block. Not proportional. These each should be the same size. Let's just pretend. So a city block, 3 times as long, 1, 2, 3, as it is wide. So it's 1, 2, 3 units wide, and I'm sorry, it's 1, 2, 3 units long and 1 unit wide. So that's our city block. We've been given this information. The distance around the city block, another word for distance around something is called perimeter. The distance around the city block is 0.48 kilometers. Okay. Here's the deal. Let's go ahead. We want our final answer to be in meters. Let's go ahead and convert 0.48 kilometers into meters. So 0.48 kilometers equals how many meters? We won't go through the long conversion algorithm. Let's just use our logic to guide this process. We all know that there are 1,000 meters that live inside 1 kilometer. Because again, that kilo refers to 1,000. So, just my Nordstrom email coming through. So if we have less than a kilometer, much less than a kilometer, how many meters do we have? We have less than a kilometer. How many meters do we have? Or let's think about it like this. We're trying to convert 0.48 kilometers into meters. So all we really have to do, you guys, is multiply 0.48 times 1,000. Because again, we're looking for meters, and there are 1,000 meters that live inside 1 kilometer. We can do this in our head. Think about the place value chart. We have 0.48. We're multiplying by 1,000, which means 0.48 is going to move to the left on the place value chart. There are 1, 2, 3 zeros in 1,000, so these digits, the decimal place is going to stay exactly where it is, but these digits are going to shift 1, 2, 3 spaces to the left. So 4/10 is not going to be a 4/10 anymore. It is going to move 1, 2, 3 spots to the left, which is going to make it 100. And then 8/100 is going to move 1, 2, 3 spots to the left. It's going to go into tens. And then we're just going to fill in our ones. We'll end up with no ones. So 0.48 kilometers is equal to 480 meters. Okay, so that's just the conversion. Now we have to apply this to the rest of the problem. Okay, so we have, let's count the units that we have in this city block. I have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 separate units within the city block diagram. The distance around this block is 480 meters. If we have 480 meters stretched across 6 units, how can we figure out the distance of each unit? Okay, I smell a division problem. We're looking for the distance of each unit that makes up our city block. The problem tells us that each of these units added together, or if we walk around the entire perimeter of the block, we walk 480 meters. So if we want to find out the distance of the length or the distance of each unit, we're going to divide 480 by 8. Because again, we have 1, 2, 3, 4, 5, 6, 7, 8 separate sides of this city block. 48 divided by 8 is what, Miss Maggie? Maggie is telling us 6. 48 indeed divided by 8 is 6, but this is 480 divided by 8. So 480 divided by 8 is 60. So what that tells us, Maggie, is that each of these units within our city block is 60 meters long. And each of these units is exactly the same. We already know there are 8 of those units, so each of these units is exactly the same. We have the perimeter. The final question, the perimeter of this entire city block is 480 meters. We divided 480 meters by 8. Now we know the length of each unit, but of course we're not done. The final question is asking, what is the area of the block in square meters? Okay, so area, we've done a lot of work with rectangles. Area is equal to the length times the width. You'll see this as you guys get older, just LW or L dot W, but right now we'll look at area equals length times width. What is the entire length of this side of the city block? Each unit, each of the 3 units within this length is 60 meters. So if I have 1, 2, 3 copies of 60 meters, Eric, can you tell me what the length is of this city block? We're just going to find 3 copies of 60, which, as Eric has already probably figured out, is 180. So this length is 180 meters. Now we need to figure out the width. Well, we know that 480 was divided evenly into each of the 8 units that makes up the city block. So if this is 60 meters, and this is 60 meters, and this is 60 meters, and when I say this, I'm just looking at this individual unit, we know the width of the city block is 60 meters as well. So our length is 180. Our width is, who can look up there? thank you, Gabby, is 60 meters. How do we find the area? Well, who can tell me how we find the area? Thank you, Kyle. The area, we simply just multiply the length times the width. Okay, so our length, and we can certainly do that. We've been doing tons and tons of multiplication. Speaking of tons and tons of multiplication, that brings me to the word of the day. Word of the day on this fine day is going to be artichoke. A mysterious vegetable, but very delicious when prepared properly. Secret word, artichoke. So, in order to find the area, we're going to multiply the length, which is 180, times the width, which is 60. I think this first piece is going to be pretty simple. 0 times 0 is 0. 0 times 8 is 0. 0 times 1 is 0. Whew, kind of exhausted after that. Now we're going to go into our second row. My hand immediately draws a 0 because my brain is telling me that we're going to be multiplying this 6 into 0, 8, and 1. But it's not a 6, it's a 60. Anything that we multiply by our power of 10 is going to end in 0. So that's why I have my 0 there already. Now we're going to look at 6 times 0. Thank you, Claire. It's 0. Now 6 times 8. Who has that for me? Anna, thank you. 6 times 8 is 48. Very good, Anna. That is my favorite multiplication problem. So we have an 8. We're going to carry our 4 over. 6 times 1. Who can look at this one for me? Thank you, Fiona. 6 plus 4 is 10. Very good. Okay, who wants to handle this addition that we have? Louie, you want to try to give this a go? Okay, bud, here we go. 0 times 0. Thank you, Sarah. I'm sorry, 0 plus 0, excuse me. But 0 times 0 is also 0. Okay, Louie, you still have this. 0 plus 0, another 0. Thanks, bud. What about 0 plus 8? 8. Very good job so far. 0 plus nothing? 0 or nothing. 1 plus nothing? 1. Okay, guys. Nice. Thanks for the help with that addition, Louie. Our final answer here is 10,800 meters. That was, I promised you, a good problem. I think that is just the best. Very good on this one. We are going to continue doing tons of problem solving tomorrow. So I would recommend that most of you rewind and watch that again. Just so you can really see every single step here. So that's a beefy problem. We're going to see these on our celebrations of learning this week. But you guys have all of the skills that you need to be successful on this. We just have to make sure to take your time and really understand what the problem is asking. That, I would say, that's most of the battle, because you guys know how to divide, you guys know how to multiply, you guys know how to convert, you guys know how to add. I mean, really, when we look at the individual pieces of this problem, those individual elements are not complicated. It's just it's just arranging them in the proper order and just really taking your time. So it's not a rush. Enjoy it. Make sure that you're being very, very precise in your calculations, and everyone's going to do great. Okay, guys, hope you enjoy the rest of your day.